Hey, John here. Today we're going to do 2 quick bits of correction on old code, and we're going to animate the process of dropping seeds into the Mancala board. First bit of correction, which I recorded yesterday on the state diagram. Okay, right now we've got a fundamental problem with our state diagram, and I think it's going to cause problems in the future. It's not causing a problem yet, but I think it will cause a problem in the future. And let me explain why. This is our state diagram as it is right now. We've all seen it. Init game, start user turn, wait for pit, animate user, AI thinks, animate AI, back and forth, and you go through this circle. At the same time, there's also the game engine who's going through the user's player turn, the AI's player's turn, and back and forth. And right now, because both of these engines are making the same decisions in the same order, everything's okay. But what if one of these, say there's a rule change that we put into the system later, to where this system gets out of sync with this, and so it's waiting for a pit, but the AI player's turn, so you can't press a pit on the AI side, or vice versa. It's waiting for the AI to think, but the game engine thinks it's on the user's turn, so it locks up there too. This isn't going to work, I think, in the long run. So to kind of simplify this, I think I'm going to make this the decision maker. So this is what I'm going to change. I'm going to change this from user turn to start turn of any kind, and it will decide, this will ask the engine whose turn is it, and then start the right turn. Either it starts the user's turn or starts the AI's turn. And instead of having these points here making a decision, we'll put that in one spot. We'll have it, both of these going back to start turn. And then the start turn state will determine, oh, do I do user turn, AI turn, or is the game over? In which case I go back here. I think that cleans up our state diagram. I think that's going to simplify things and make for a cleaner game in the long run. Next, a bit of correction on how to handle startup of the Kiwi class. I've learned a little bit more about the Kiwi app class, and it turns out my overriding of the init function here, right here, is not really necessary. There is in fact a built-in function called onStart that will in fact start up or be invoked whenever all the Kiwi routines are fully active. So I'm going to go ahead and move that code over here. And I should be able to just delete all that. Oh, yes. All right, all's good. Let's go ahead and make those state changes. Well, appears to be all working. And I actually won a game, hooray! 22-26. Let's go ahead and get the animation going. Okay, I'm partway there. Got the bulk of the hard work done. Now if I choose a house, I'm not animating the user side yet, I'm animating the AI side. So the AI is thinking, and it's taking way longer than before. And I think the reason why that is that I'm building that move combination. Here, I'll show it to you in a second. Okay. Yeah, there's some flaws still. Okay, did a pickup. Now it's dropping seeds again. Dropping some more seeds. The AI, I think, is taking longer because I have a whole bunch of string operations occurring now that I'm trying to store the animation. Let me show you the code changes I've made, and then I'm going to do even more fix-up. Here in Animate AI Choices state, I am going to a common routine I'll be using for both sides where I'm building the hand animation, or really I just need to say build animation or something like that. Well, at any rate, saying what player's going and also what are the animation moves, and I'll show you that inside the game engine in a moment. Binding it as I did before, using it on the AI hand here instead of the user hand, which makes more sense. So up here, here's the player, here's the steps that it's going through based on what action it's doing: scoop, drop, drop ball, steal, or game over. Again, I'll show you that in the game engine in a second. It's actually making those animation moves until it's got, then it builds them all together and sends back the hand animation. I'm not showing any messages on the screen yet. I got to figure out a way to coordinate both the animation moves as well as the messages that change on the center screen. So I got a little bit of play to go there. I've also added something. I've got another magic list of pits here and of hands showing the position for each of those positions. So when the animations are going through, it actually it's got a reference table to go through, so I can use that for multiple locations, which is good because I'm also using that now in the Mancala.kv file. So for each one of the hands, so this is hand number 1, instead of putting in the position manually, it's now referencing that table in other files. So root.hands position 1, what's the position? And it puts that into there. Also, something newly introduced is true spot. So instead of using the bottom lower left-hand corner of each image, it's now using the center of it, which is 150 by 150 pixels in, because we have a 300 by 300 image being used. So now I can grab things by the center and move things around by the center. So that's the changes in Mancala KV. Now I'm going to show you the changes I made in the game engine. Now at the start of initializing the game, I have self.animate property, which starts out as an empty list. And then down here, every time I do an action, here it is, def scoop, where I got 3 main actions. I got scoop, drop, and drop all. Now it actually adds animation instructions. So I'm adding a dictionary to the list. This one's scoop, and it tells me what pit I'm scooping. Here I'm dropping, what pit I'm dropping, and how many seeds I'm dropping. And then drop all, again, the pit and then the count. It may not be important to distinguish between these two types, but I'm adding it in there anyway right now, and we may play with things later. So essentially, it's just building up a list of dictionaries showing what actions are occurring when it's doing the move. And then, of course, here under play move, or make move, excuse me, I'm resetting it. So every time you make a move, it resets it to an empty list. It builds the list of animations that need to be animated, and then it leaves it there so we can get to it after the move has been made. I'm going to have to do 2 things here. First off, I'm going to make it so that I only build this list of moves if I'm in fact playing a move directly. And the reason why is that this adds a little bit of overhead to our moves, which if I'm actually making the move, like the user's making the move or the AI is making the move, that's a trivial amount of overhead. But when we start running the AI function where it's trying to think ahead in the future, it's actually also running make move, but not once or twice, but thousands, if not tens of thousands, or maybe even hundreds of thousands of times, trying to simulate all possible moves into the future. And it's doing this overhead and then deleting it every time. So it's actually a phenomenal amount of new overhead. So I'm not surprised it went from about 1 second to about 5 or 6 seconds to run. So I'm going to make this to where I've got some kind of flag. I don't know what I call that flag, but where if I'm in the middle of the AI, don't do all this stuff. Excuse me. So I'm going to go ahead and make some of these changes. I'm going to make it so this building of the animations only going to occur when we're outside of the AI. I'm going to make it to where it both animates the user side and the AI side on the screen. And I'm going to figure out a way to get where I can both display messages between hand movements and actually do hand movements. I got a little bit of tweaking to do. Let's see how it goes. Okay, it kind of works. So I can choose a house now. Let's make this a double move. So goes to the right pit, drops all the pieces, land in the store, play again. It's not changing the individual pit numbers as we're moving along. I have to get a little bit more advanced there. Okay, here's the AI moving after it's thinking. I sped up the AI a little bit. It's not perfect. I got some more tweaking to do there. Now it's making its second move. Again, it's not updating the pit numbers, which is fine. Let me show you some of the things I've done. I've created the animation routine again. I've made it into more of a list rather than a built-in sequence because I need to modify multiple widgets, including the text and the hand itself. And later on, I'm going to be adding in seeds, and of course, be modifying the labels. And given if I use the built-in animation sequences, I seem to be really limited. I can't get into the middle of the sequence. It just goes on its own, which is great sometimes, but in this case, it's going to cause me a problem. So when I build the animation, I went and made it generically called build animation. I make a hand list and a message list, and later on, I'll probably make 2 more lists. And the lists are of equal size. So all I'm really doing is changing the position. Later on, I'll be doing a little animation and a little bit of like image manipulation and that kind of stuff, but also adding to message lists at each state. So I'm actually setting up the number of steps for the animation, and all the lists will be of the same length. So return the hand list and message list, and then when I'm using it, let's go down to here. So animate user choice. So I build the animation given the current player and get the animation seen in the system. By the way, I'm now using something called user move simulate choice. Let me actually show you, let me diverge for a bit and go over show you how to do it in Game Engine here. I need to be able to do half move choices rather than displaying an entire turn. That's a challenge here because, well, let me show you what I've done. I've created these 3 functions: user move start simulation, user move simulate choice, user move finish simulation. And it allows you to make a temporary copy of the game just to do the half turns, the choices, and then restore back to the original game so you can play a proper move when it's finished. So here it is, setting the animation to nothing. Original board is copied from the current board. And then in user move finish simulation, I can, again, I reset the animate and I restore the board back to its original condition. So as long as I remember to always start and finish the simulation, I won't mess up the game. And then for simulating an individual choice, it places the last choice done so far in its temporary copy of the game. And with that, you can actually get the animation back after this simulate choice is run. So let's go back to the main app here. So user move simulate choice. Run it right at the top here when it's doing the choices so far. Now I've got the list of building the animation, and it goes and runs done moving hand right off the bat. And the reason why is at the very beginning, there's always going to be entries in this move list that I got back from. I got a move list and a message list. That's for the hand, and that's for the messages in the center of the screen. If I'm not done with it, I'll actually show the next move, change the center text, and update the index counter and return same state. So I don't want to change states. I want to stay here. So, and this triggers back on itself. So where's the binding here? Move list, the current can place in the list, bind on complete, done moving hand, which is where I'm at right now. So every time it does one move, it goes back and it'll loop until this list is finished. And at that point, it'll actually, if it's done, over here, it'll finish the simulation than actually play the move on the correct original board. Otherwise, it goes back and says, landed in store, play again, so you can do the next half move, and it'll loop back and forth. Very similar setup was done for the AI, but other than I don't have to deal with the half move thing. I just play the whole sequence in a row, and I can update text and that kind of stuff as we need to go along. So, it seems to be working. If you like what you've seen so far, please subscribe. Thanks.